I'm back with another JavaScript code. This time it demonstrates the usage of object-oriented programming. The project is called For Friend. It is for the people who are hesitant or unable to adopt real pets. So the interface allows them to adopt pets like dog, cat, or rabbit. This the code is developed in such a way that you can add in more pets in the future based on the object-oriented principles. So all of these details, as in this is the business requirement that you're seeing on the screen, all of these details will be put down in the comment or the description box, which you can go through. Let's just dive into the UML class diagram. So hopefully you'll be able to see this. So we have a user just adopts a pet, as in say when you log in, you just say adopt pet, and the pet manager is responsible for creating that pet without the user knowing what is really happening with that pet, right? So we have a pet status class, we have interaction handler class. Obviously the pets would play, cuddle, you should be able to share thoughts, feed the pet should be able to rest. And we also have inheritance here, because your pets have certain other activities that they do, correct? So, and then the game manager that provides abstraction to your code. Here are the few we've also created low fidelity mockups of how the application would look like. This is a very good way for you to show your clients or users what is your thought process, and if everything that you're thinking is right. So there will be a login page which allows you to log in through all of these: Apple, Google, Facebook, and then you have pets that are available. You can name your pet, and here is the status of the pet. Obviously you have to make sure your pet is healthy and the hunger is in check, happiness, energy, and all of that. And so this is pretty much it with respect to the documentation part of it, which obviously if you want to go in detail, you can look into the description link. I also add the GitHub link in the description box. Let's just dive into the code. So here is my readme file. What it does, so there are certain features that I've added: pet adoption, pet status dashboard, interaction, and mental informations, and all of that. Ways to download the code and run it is provided in the readme file. So what is encapsulation? Encapsulation is basically you're making sure that certain attributes or methods that belong to a particular class are not allowed to be modified, or like say encapsulated within that particular class. Where have we done it? If you go to pet, in pet class, so we have changed the species and status of this particular class, or say attributes of this class, to private. So this will make sure that nobody can modify the species. Like say you might just say ki hey, you can instantiate pet, and say if this was not private, you could just add one more species like dragon. But now since it is private, it will not allow you to modify it. It will only allow the species that are actually there, and you can modify it only through update status. You can update the status to update status and get the species through getter, that is get species. So that is with respect to encapsulation. And with respect to abstraction is basically means that you do not let the user know what is the background details about a particular code. As in say in our case, we have interaction handler, right? Now there is a lot of code associated with, like when you update a status, when a pet plays, so what is the energy level or the health level that gets increased, or how much hungry does he feel, or say how much happiness does he get. So the user should not be able to know that. They should not be able to modify it, or like say they should not be bothered about it. The only thing that they're bothered is playing with the pet, and whatever happens in the background should be taken care of. So that's what is being done. So anything that the modification part is taken care by the code, abstracting with the user. Apart from that, let's go back to readme again. Inheritance. As it says, inheritance is basically you can inherit certain values, like say animal. All the animals have certain attributes that are common across, whereas every animal might have certain different attributes, like say the dog can bark, then your rabbit can nibble. Likewise, you might want to add certain things that are specific to those classes, while adding more details that are common across. So this is done in cat, dog, rabbit. If I go here, if you see here, it says class dog extends pet. So pet is a base class that has basic properties. If you see here, it has a name, it has species, it has status manager. uh, while these attributes are being used, are common for the dog also makes a sound. Dog barks, so barks oof oof, right? So dog fetches. Likewise, if I go to cat, it is make sound, yes. Cat also makes sound. It does scratch. So this is something new that is there in the inheritance part. And if I go to polymorphism means you make use of the same function across, but override it, as in you have different values to within these functions. If I go to, we just saw in cat we did have make sound, but then it purrs. So this is a different value. If I go to dog, will bark. If I go to rabbit, it twitches, right? So these are the things. It's the same function, or like say method, but has different return values associated, which is polymorphism. Now we have other things that are taken care of as well. There are solid principles. Single responsibility ensures that there's one particular class has only one responsibility. If we go to user is only responsible for managing user details and adopted pets. Species stores available pet species. Interaction handles only interactions. Game manager manages the game state. So everything has one responsibility, which is covered. Open and close principle. Uh, it is it just means that your code is open for addition and closed for modification, as in you can add more stuff, whereas you do not need to modify stuff to add new things. So if you see, interaction handler allows new interactions to be added without modifying existing code. So even the pet species list, so it has, if I go to pet species, so there's a list. So static species list, so you can just add dragon. You want to adopt dragon or whatever, like, right? So you can add it in here to make sure that it's taken care of. And if I go to Liskov substitution principle, so in this, whenever you modify the subclasses, like say dog, cat, rabbit, should be substituted for pet without affecting the behavior of the system, right? So likewise, it has been taken care of in our code. If you see dog, this is still a pet, right? And if I go to dependency inversion principle, so pet class has depends on abstraction status manager rather than pet status, which means that it is dependent on status manager and not pet status. So there's the abstraction between these two classes. And design principles, if we go to design principles, there's singleton pattern that is being used, making sure that only, if you see game manager, ensures that the instance is static, which means that the game manager exists only, there's only one instance of game manager that exists. And we have the bad example in here as well, if you want to have a look at it. Factory pattern is make sure that your pets are created dynamically. It's if you it's more of what you think, right? It's a step by, it's kind of how do I put it? It's like a factory that creates a lot of pets. Like you just say, hey, I need a pet, but and then it creates it for you with all the necessary details that are required. And strategy pattern, which ideally means that there are like different ways to update pet status without hard coding or modifying the logic associated with it. So that's pretty much it. All the code is available on GitHub, which I'll link it down. And yeah, that's it. Thank you for watching. Bye.